Hello students, welcome to lecture of kinematics and theory of machine. Myself Patel, and we are going to continue our chapter gear trains. So in this chapter, our topic we will cover is the last type of gear train, which is a epicyclic gear train, and we also complete the example of epicyclic gear train. Okay, let's start. Okay, let's start our last type of gear train, which is epicyclic gear train. It is very important type of gear train, and mostly our numerical are based on this type. So let's start. So first of all, what is the name of this gear train? It is epicyclic. It is you can see from the name epi. Epi means upon, and cyclic means around. Means when one gear is rotating around some any other gear, then it is known as epicyclic gear, arranged in such a manner that one or more of their members move upon and around another member, and it is known as a epicyclic gear train. Okay, let's see the figure. You can see here the gear A is at a center, gear B is moving around gear A and connected by this arm. Arm is given the notation as a C, arm C. Okay, so when if I am rotating the A, it will rotate the B. Okay, so epicyclic gear train is very useful because it reduce, or you or in simple language you can say very high velocity ratio in limited space can be obtained by this. Okay, so but in this particular case the method of obtaining speed ratio will be changed. You find the speed ratio by RPM of the driver upon RPM RPM of driven is equal to teeth of driven upon driver. But in this epicyclic, this one gear is moving around, and the shaft of this second gear is not steady. It is also revolving around the center gear. So method will be changed here, and the method we will use to find the velocity ratio means if the RPM of this gear is N1 and we want to find the N2, what will be the procedure? And in this case there will be RPM of arm also. This arm is also revolving. Okay, without considering these two, I can say that if the arm is rotating one complete revolution, how many RPM this can be for this gear? So this type of question may be arise, and we can find by the using tabular method. Okay, very simple, and mostly all numerical we will solve based on this numerical tabular method. Okay, so this tabular method is based on one table. We will make always any gear, any type of system can be asked, but as an example for learning this method, we taking this simple mechanism, simple system in which gear A is at a center, arm is here, and gear B is rotating around it. Okay, so very simple system of these gears is taken, and we will find the velocity of A, B. Okay, so let's start. So pay attention, it is very important method for it, all the numerical based on this tabular method. Let's start. So first of all, you have to make this table in which how many columns will be there. First of all, serial number, or you can say step number. There are 4 steps, 1, 2, 3 and 4. Okay, after that, condition of the motion, and then there is the arm. Always after condition, I'm repeating again, in first there will be steps, in second there will be condition for the motion, Okay, in after condition of motion, always there will be first will be arm. Okay, and after that there will be all gears. So starting will be done from the arm. So first of all, whatever the arm, here the name of the arm is given as a C. Maybe the that can be, if it is not given. Okay, if it is not given, you can use as a O1, O2. So you have to write here O1, O2 if any name is not given. And if is anything not given, means no data is given about the arm, you can write only here the arm also. Okay, so first column will be fixed. Okay, and it will be arm. And after that you can start with the all gear. If there is a gear, right here B. After that, if there is a other gear is C and D. Okay, maybe number of gears may be increased up to 6 gear also there in one example. So whatever the gear, start with any one gear and one by one, or means A connected to B, so B will be after A. There is a C, B and C connected, so B after B there will be C. So that's why in this manner you have to write all the gear and arm in this manner. Okay, and this column is represent the revolution of element, means RPM of C you can find from this column, RPM of gear A you can find from this gear, and RPM of C you can find from this column. Okay, let's start. What will be the first row? So first row, see, the arm is fixed, and gear A rotate +1 revolution. Okay, remember that anti-clockwise we have taken as a positive. Anti-clockwise is a positive and clockwise is a negative. Remember that. Okay, anti-clockwise we have taken positive for all numerical, and clockwise will be considered as a negative. It is very important because you find the driver's RPM is not enough. Means if you find the RPM of A something like here 200, but if you had not given the sign minus or plus, means you don't know the in which direction it will rotate. So remember that anti-clockwise means plus. So what will happen? So first of all we have the arm fix, means arm fixed, so RPM here will be 0, and the first column whatever we have put it in this first column, we make the one complete revolution for that gear. Okay, +1, so here will be +1. So always remember that you can choose any gear for this first step. You can write also there is a gear B and here also A. So and all the C, D will be behind that. So okay, first of all let going for the second row. In this second row, first of all what we have done, the arm is fixed. Okay, arm is fixed. So in this first column the RPM of arm is fixed, so means RPM of arm will be 0. Okay, and after that we have taken second condition, A rotate through +1 revolution. A rotating is a +1. First of all check this anti-clockwise. We have taken one assumption that anti-clockwise means positive and clockwise is negative. It may be changed book by book, but final answer will be same. Okay, because if you write some answer like RPM N is equal to, you have written as a 400, so RPM, but it will be wrong, because if you write this without sign plus or minus, or you can have to write that clockwise or anti-clockwise. Okay, so first is the arm fixed, so here will be 0. Second, A gear, we assume the A is a main driver. Okay, and if it rotate complete one revolution, then RPM is given as a +1. So how this came here? Let's check it step by step. So first of all, you know that A and B is connected in a simple gear way. Okay, in a simple gear way. So you can write this NA is equal to NB is equal to TB upon TA. So you want the RPM of gear B. So you have make the subject NB and TA upon TB. But you know that RPM of A, gear A. What is the RPM of gear A? It is 1. How this come? You can see here. The gear A has +1 revolution, so NA is equal to +1, and after that, so you can write that NB is equal to TA upon TB. Okay, so after that, second row, in second row, you what you will do, arm is fixed, again same condition, but A, revolution of A is at some x. If I am going to revolve at some x revolution, what will be the RPM of B? Simply it will be multiplied by x. Why? Because you know that relation NB upon NA is equal to TA upon TB. But if you know that there is a RPM of A is equal to x, so you will write here x. Okay, and NB is equal to what will happen? X will be multiplied here, and you can find this. Okay, so that's how you find the NB. So some student have a doubt, sir, why NB is equal to x into T upon TB? Why we have this value written here? Always remember that whatever you writing here, it is the RPM of A. You are writing here is a RPM of B. Check this, revolution of element. Means whatever you have written here will be considered as a NB at the end of table, and here will be RPM of NA, and here is a RPM of C. Okay, let's, after that you have added plus y to all. Okay, and then total, in total you have to sum these two data. Okay, not the first, ignore the first. So sum of column, row 2 and 3. In total motion 0 plus y is equal to y, x plus y is equal to x plus y minus x TA upon TB. So you have written that y minus x TA upon TB. Okay, there is a TA. So this is the method for the tabular, for the table of epicyclic. I will repeat again, and I am going to show you how this table will be useful starting. Okay, so in second column there is a condition, and after that always write the arm, and after that, if there in this system maybe other gears will be there. Okay, there will be other gear, and among them consider one gear, one maybe almost outmost gear or at a center wheel. Any one of them take as a main gear and write here, and one by one check that A is connected to B, B is connected to C, means how the motion is passed through, and make as the column, means how many gears are there, make these columns here. Okay, after that start with the first row. Always will be there, arm is fixed, arm is fixed, always will be there, and first of all give the +1 revolution, and after that plus x revolution. So here will be 0 always, and here will be +1 and plus x. What will be the change in here? Check this, always at top will be the teeth of A, means whichever gear you have taken. If I am taking the gear C here, then here will be TC, because for table there will be driver upon driven. Remember that in table always the teeth ratio comes at a driver upon driven. So whatever the gears are there, driver will be always this consider. Okay, so minus x. Why there is a minus x? You know that if I am going to give anti-clockwise direction, if it is rotating anti-clockwise, which have we consider as a plus, so this gear B will rotate in a clockwise direction, so indirectly it will be considered as a minus. So that's why minus sign is here and here is taken, because our assumption is a +1 anti-clockwise direction, and here plus x revolution, but it is also anti-clockwise. Okay, after that you have added plus y in all column, and you will find this is the main column, main output of our table. Okay, plus y plus x plus y and y minus. What they indicate, whenever some data I have and I have want to find the RPM of C, it will be considered as a plus y. If I want to RPM of this A, then it is considered as a x plus y, and if I want to find the RPM of the B, it will be considered as this y minus x. Okay, TA upon TB. Clear up to this point? Let's check one example and you will know how this table will be useful. And before starting that, I am going to give you 2 tips for all example of this gear train. First of all, make the table. After table, there will be always 2 RPM is given. Always any 2 component, for any 2 component RPM is given, and among these 2 component always given one RPM, one component as a fix. Maybe they say gear B is a fix, arm is fixed. If they say gear arm is fixed, so there you, and indirectly they have given the RPM of C and is equal to 0, and other RPM is given. So they always give 2 RPM, any 2 component with RPM, like I can say here 100, and using these 2 data we will compare here, like here is A, so sorry, consider the RPM is given, NC is equal to 0 and N is equal to 100. We will compare this data with our table, and what we will find? We will find X and Y. Using these 2 data we will find X and Y, and after, if you find the X and Y, you can find the any RPM of any element in our system. Okay.